Lastly, today we are talking about the third state of matter, which is gas or gases. So I am actually on page 92 and 93 of our science books. Gases. The air in your bicycle tires is a gas. The helium in a balloon is also a gas. A gas has no definite volume or shape. Like a liquid, a gas takes the shape of its container. The air in a tire takes the shape of the tire. If you pump air into a soccer ball, it takes that shape. If you pump the same amount of air into a football, the air takes that shape. Gases are different from solids and liquids. A gas expands or stretches out. It takes the volume of its container. That means that it fills all the space inside of a closed container. A gas keeps expanding until something stops it. That something may be any kind of container or closed space. A tied balloon and a bicycle tire are examples of closed spaces. You can use jars to compare how liquids and gases fill containers. When you pour water into a jar, all the water goes to the bottom. As long as you do not tip the jar, the water does not come out. When you allow air to fill a jar, the air does not all go to the bottom. Instead, the air fills the jar evenly. Without a lid on the jar, the air will expand and escape. So guys, what is a gas? You guessed it. It's anything that has no definite volume or shape. Let's look at the picture on page 92. Do you guys see the picture of the guy riding the balloon or riding the bike with the balloons attached? Once you find that picture, I want to know, what are the gases in this picture? Can you guess any of the gases? My guess is the balloons have air inside and the bike tires also have air. The gases in that picture are the air in the balloons and in the tires. Can you see the gas? No. Do you guys remember some of the gases that we've already talked about this year? Oxygen and carbon dioxide, the ones that are a part of photosynthesis. So let's actually compare gases to liquids. So for example, a gas takes the shape of the container. But it also takes the volume of the container. So I think they differ in this bottom one here. For example, the liquid takes the shape of the container and the gas takes the shape of the container, but the liquid keeps its volume. Remember, even though we poured it into the bowl or the glass, it was still 200 milliliters of water. But a gas takes the volume of the container. It takes the volume of the container. So it's going to fill up that container and change its amount of volume. For example, the amount of air in your bedroom is going to be a different volume than the amount of air in your living room, unless, of course, they're the same size. So I want to know, if you blow up a balloon, what gas are you putting inside of it? You guessed it, either air or carbon dioxide. That air takes the shape and size of the balloon. So what shape does the air that fills this room have? Well, of course, it takes the shape of the room. I'm in our classroom, so it's taking a rectangular shape and whatever else is filling up. So what do you think stops a gas from expanding? You guessed it, a container or a closed space, such as a bike tire. There's only going to be so much air in that tire because the tire itself is containing the air. It has nowhere else to go. A balloon is also a closed space. So guys, I want you to look at these two containers. I have a container here with nothing inside of it but air. I have a second container with water in it. So the blue one has the water, the red one has the air. What do you think think would happen to the water if I take this lid off? Let's see. Nothing really happened. The water stayed at the bottom of the container, see? Nothing happened, the water stayed there. What if I took the lid off of this air? What do you think happened to the air? You guessed it, it didn't stay in the container, did it? It expanded and went out into the room. It didn't stay closed or in the bottom. It came out and expanded into the rest of the classroom. Okay, so let's go back to our two containers here. Can you see the top of both the water and the air? Can you see the top of the air in here? And the top of the water? Well, I actually don't see anything inside here. I don't see any kind of top of the air, but I do see the water line. I do see the top of the water. I can determine that. Why do you think you can't see the top of the air in this container? Why do you think so? You guessed it. Because air is a gas, it expanded and completely filled this entire container. We can't see the top because it's filling the entire thing, whereas this water is only filling a portion of the container.